All right, we're still working on section 5.6 of your intermediate algebra book. We're going to start with example 5 on page 208. Above example 5, there's just some explanation of what complex numbers are. A complex number is really a hybrid form of an imaginary number and a real number in two different terms. The standard form of a complex number is the real number plus the imaginary number as the second term. So in example 5, we're going to add and subtract some complex numbers. Letter A says 3 plus 4i. That's an example of what a complex number is. Here's the real number part and the imaginary part as the second term. 3 plus 4i plus another complex number, negative 1 plus 5i. Adding and subtracting complex numbers is just like combining like terms. As long as there's a plus sign in between here, you can drop the parentheses and just combine the like terms together. So the real numbers, 3 plus negative 1 makes 2. And then the imaginary numbers, 4i plus 5i makes 9i. And that's how we write that. For letter B, we have 7i minus the complex number 3 plus I. So this is a case where you have a subtraction sign here, and just like with regular polynomials, when you have a subtraction sign in front of your parentheses, it has to get distributed to every term there. So this is going to turn into 7i minus 3 from this negative times this 3, and then this negative times this I makes minus I. And then we write the real number first, negative 3, and there's nothing to combine with that negative 3 because these two terms are both imaginary numbers. So we'll combine those together. 7i minus I makes 6i. So this would be plus 6i. All right. Letter C is at the top of the next page. It says 5 plus 9i minus negative 4. So this is kind of similar to the one above where we have a subtraction sign outside of parentheses, and this has to get distributed to this negative 4. So the first thing we're going to do is rewrite this as 5 plus 9i plus 4, since you have those two negatives here. So this turns into a plus 4. Then we add the real numbers together. 5 plus 4 makes 9. And then we have just this one imaginary term. So it'd be plus 9i. All right, letter D. Says 6 plus 2i minus 12 minus I. Again, with a negative symbol here, that has to get distributed, so that's the first thing we're going to do. We're going to simplify this, drop the parentheses. So 6 plus 2i, and then that would be negative 12 and a positive I. This negative times this 12 gives you negative 12. Negative times negative I gives you positive I. And then we combine the real numbers. 6 plus negative 12 makes negative 6. And then the imaginary numbers, 2i plus I makes 3i. Okay, for example 6, on page 209, we're now going to start multiplying complex numbers. So letter A is 5i times 2i. And multiplying imaginary numbers like this, since these are both monomials, is just like multiplying any kinds of terms with variables. You multiply the coefficients first, so 5 times 2 is 10, and then you multiply the i's together. I times I is I squared. What you have to remember is you have to simplify I squared. And we didn't write it, but we will write it right up here. I squared equals negative 1. So this is 10 times negative 1, negative 10. Letter B says negative 3i times 4i, and we're going to do it just like we did the one above. We'll multiply the coefficients first. Negative 3 times 4 is negative 12. And then when we multiply I times I, we get I squared. But you have to remember that I squared equals negative 1, so we always simplify that I squared. So we end up with negative 12 times negative 1, which equals positive 12. For letter C, we have 7i times 1 plus 5i. Now, this is a binomial, or two terms here. This is a monomial. Whenever we have a monomial times a binomial, you distribute. So that's what we're going to do. We're going to distribute here. 7i times 1 is 7i. And then 7i times 5i, multiply the coefficients first, you get 7 times 5 is 35, and then I times I is I squared. Now again, we're going to simplify this I squared is negative 1. So we end up with 7i as the first term plus 35 times negative 1, which is negative 35. This is the real number here, and this is the imaginary term here. So we need to flip the order here to put this in standard form. The real number goes first. So that's all I'm going to do as the next step. I'm going to write this as the real number first, negative 35 plus the imaginary term, 7i. Letter D says 2 plus 9i times 2 minus 9i. And of course, when you have a binomial times a binomial, there we go. A binomial times a binomial, you do double distribute, or what you commonly call FOIL. So we'll multiply the 2 times the 2 first, which gives us 4, and then the 2 times negative 9i gives us negative 18i. And then we'll multiply 9i times 2, which gives us a positive 18i. And then 9i times negative I gives us negative 81i squared. Now we need to simplify. I hope you recognize these are like terms in the middle, but they're also opposites. With the negative 18 and the positive 18, these two terms cancel. So they will be gone. So what we really have here is a 4 minus 81 times negative 1, because I squared equals negative 1. So 81 times negative 1, which simplifies to make 4 plus 81, because you have a negative times a negative, so we now have plus, which equals 85. All right, for letter E, we have 4 minus 5i times 1 plus I. We're going to do the same process we did above, double distribute or FOIL. 4 times 1 is 4. 4 times I is 4i. Negative 5i times 1 is negative 5i. Negative 5i times I is negative 5i squared. And now we're going to simplify. These here in the middle are like terms. Positive 4i, negative 5i. So we'll combine those like terms. We have this 4 at the beginning. Positive 4 and negative 5 make negative 1. So we're going to have negative 1i. And then this, I'm just going to carry this over here to the side. Negative 5 times negative 1. That's what this is. So that makes plus 5. So we end up with 9. 4 plus 5 is 9. So 9 minus I. This 4 plus this 5 makes the 9, and here's the negative I right here is the second term. All right, one more in this example, that's letter F. Letter F says 11 minus I squared. So you have to recognize and remember that this exponent is not going to distribute in. Exponents do not distribute over plus and minus signs. Instead, this exponent means there are two of this binomial being multiplied together. This is 11 minus I times 11 minus I. And then we're going to use double distribute to simplify that. So 11 times 11 is 121. 11 times negative I is negative 11i. And then negative I times 11, again, negative 11i. Negative I times negative I is positive I squared. And then we're going to simplify. So these are like terms again, and they don't cancel each other because they have the same sign. So we have 121 here. Then we have negative 22i. Negative 11 plus negative 11 makes negative 22i. Then we have this negative I squared over here, which is, I'm sorry, it's a positive I squared, and I squared equals negative 1. So this turns into a negative 1. Now we're going to simplify a little bit further because this 121 and this negative 1 are like terms. So 121 minus 1 makes 120. And then we have negative 22i. So this 121 and this negative 1 give you 120. This negative 22i here. Okay, we're going to go on to example 7, which is dividing complex numbers. And example 7 actually starts on page 210, but at the bottom of page 209, you have a definition of complex conjugates. And if you remember from a previous lesson, a conjugate is just a binomial that has the same terms with the opposite sign in the middle. So a complex conjugate of A plus BI would be A minus BI. And we use complex conjugates to get rid of complex numbers, the imaginary number, in the denominator of a fraction. So we're going to start with example 7 on page 210. Letter A says 2 minus I over 4 plus I. And you might want to try and do some division and reducing, but the fact of the matter is you can't reduce terms when there are plus and minus signs. You can only reduce factors. So unless these factor, we're not going to be able to reduce it at all. Instead, we're going to rationalize it or get rid of the I in the denominator like we did with radicals. So to do that, you use the conjugate. The conjugate of 4 plus I would be 4 minus I. So we're going to multiply times 4 minus I. But whatever you do in the denominator, you also have to do in the numerator. Okay? And really, you need the parentheses because this is going to be double distribute or FOIL in the numerator and the denominator because there's two terms. So what we're going to get here, we're going to do the denominator first. Let me scroll this up. We're going to multiply 4 times 4, which gives us 16. And then 4 times negative I, which is negative 4i. And then I times 4, which is positive 4i, and I times negative I is negative I squared. And then we'll simplify it. These two terms cancel each other because they are the same but with opposite signs. So we can cancel those off. And this negative I squared, remember I squared equals negative 1. So this is negative 1 or plus 1. So 16 plus 1 in the denominator here is 17. In the numerator, you're going to have 2 times 4 is 8. 2 times negative I is negative 2I. Negative I times 4 is negative 4I. Negative I times negative I is positive I squared. So we need to simplify that. What are we going to have here? Here's an 8. These do not cancel each other, but they are like terms. So we'll get 8 minus 6I, and then we have this plus I squared. I squared equals negative 1, so this is going to be plus negative 1 or minus 1. We still have that 17 down there. And then we simplify this. 8 minus 1 is 7 minus 6I over 17. Now some professors will want you to write this in standard form, which just means to separate this into two terms. So this denominator belongs under both of these terms. So standard form for this would be 7 over 17 minus 6 over 17 with the I kicked out to the side. All right, so we're going to go on to letter B. Which says 1 plus 2I over 5 minus 3I. We're going to use a conjugate. So the conjugate of the denominator is 5 plus 3I. You always use the conjugate of the denominator because the idea is that you have to get rid of the I in the denominator. It doesn't matter if I is still in the numerator. We just can't have I in the denominator. So we're going to double distribute for this. That's 25 plus 15I, then minus 15I, then minus 9I squared. And we're going to simplify that. These two terms cancel, so we have 25, and this negative 9 times negative 1. Do not forget, this is negative 9 times negative 1, which is plus 9. So 25 plus 9 in this denominator gives you 34. And then we're going to do the same thing in the numerator. 1 times 5 is 5. 1 times 3I. 2I times 5. 2I times 3I. And then we're going to simplify. We still have a 34 down here. So what do we have here? These are like terms, and this is going to turn into 6 times negative 1, and I'm going to rewrite that as negative 6 so that I can combine these like terms. 5 and negative 6 are like terms. That makes negative 1. And 3I plus 10I makes 13I. But again, we're going to write this in standard form. So we'll just separate these two terms. Negative 1 over 34 plus 13 over 34. Kick that I out to the side. All right, letter C. letter C says 10 over 9i. This one's different because you don't need a conjugate if there's only one term. If this is a monomial, you can just multiply times I in the denominator and I in the numerator, and that will just simplify. In the denominator, this makes 9i squared. That's 9 times negative 1, which is negative 9. In the numerator, you have 10 times I, which is 10i. And this would be okay, except that we don't leave negatives in denominators. So you can just pop this negative up here to the front and kick that I out, and you have negative 10 over 9i.